everyone. Today we are gonna start momentum and impulse. Grade 12 physics. This is our first lesson for momentum and impulse. Today just we are gonna explain what is momentum, what's impulse, and then we are answering with you 5 easy questions, not from past papers, easy questions just for practice. We are gonna answer some questions. This lesson and next lesson we'll try to finish all definitions, everything about momentum. After that, we are gonna start all past paper questions. All right, so let's start. What is momentum? Number one, momentum. Momentum of a particle is the product of an object's mass and its velocity. This is our definition. They are asking you what is definition of momentum, define momentum. So this kind of questions coming, please be ready with 2 marks. And then formula of momentum. As you see from definition, they said product of mass and velocity. See, momentum equals mass times velocity. This is our formula. P equals m times v. And then units, unit of velocity, unit of momentum, kg times meter per second. Kg times meter per second. We are using unit of mass, unit of velocity. That's it. Kg times meter per second is unit of momentum. I hope everything is fine. Just let's continue. Change in momentum. Other name is impulse. Change in momentum or impulse, same thing. If you have an object, if you have just object with initial velocity, let's just explain this one, how we are getting this formula. Let's write it down. We are gonna get, okay, let's use. If you have one object, initial velocity, let's say vi, the initial, you have one object, mass is m, we are showing with m. Let's say we're just moving this way, v initial. And then speed up or slowing down, but change velocity. Object now with v final, vf, we are showing with vf. So if you have this kind of change, maybe different direction is also fine. So delta p giving you impulse. Delta p equals p final minus p initial. And then p final equals mass times v final. And then p initial is equal to mass times v initial. And you can write delta p equals mass times delta v. I hope everything is fine. Change in momentum. Other name is impulse. All right, let's continue with next question. So next question, always we are answering questions. Now we are explaining what's impulse and momentum. So impulse, second one, second definition we are going to ask you people. First one, momentum, we should know in this topic what is momentum. And second one, impulse. Impulse is the product of the net force acting on an object and the time the net force acts on the object. So if they ask you this question, exactly the same thing, just you should write. If you just forget about one word, just you are going to lose your mark. So please be careful about that. What they said, product of net force and time. So we are having another formula for impulse, force times delta t. So m times delta v, we know already, change in momentum, m times delta v. As you see, we have another formula for impulse. How we are getting that formula, let's explain. It is coming from Newton's second law. F net equals what we know, F net is equal to mass times acceleration. And then what was the acceleration formula? Delta V over delta T. F net equals m times delta V over delta T. From motion, you remember that? Delta V over delta T. All right. So, when you just make cross multiplication, F net times delta T, you can write over 1. Our writing pad is making problem today. It's fine. So, F net times delta T equals m times delta V. So what we know, what was the m times delta v is equal to delta p, right? Impulse. So impulse is lucky. It has 2 different formula. m times delta v or f net times delta t. So we can say f net times delta t equals m times delta v. Impulse equals f net times delta t. And from this formula, we are writing definition of impulse, product of net force and the time the net force acts on the object. So we are using this formula to write our definition. All right, I hope everything is fine so far. Let's continue with next slide. Let's see what we have. Next one. Yeah, okay. Next one, question. All right, from now we are going to start questions. We have 5 questions today. So far, what we know: impulse, momentum, definitions we know, and then some calculations. M times delta, M times V giving you momentum, M times delta V is giving you impulse, and F times delta T giving you impulse also. Impulse has 2 different formula. So now, from now, what we're going to do, we're going to answer our questions, but we should explain one more thing before we start questions: direction. So we are going to choose just positive and negative for direction of velocity and direction of momentum. So if you are choosing east or right, you can say just east, let's say positive. You can choose opposite, it's fine, or negative, it's fine, but I want to choose just exactly the same for each question, for every question, to make it easy for me. So east, another one is west. West, let's say negative. So if it's going up and down, if it is going up, let's say positive. If it is going down, let's say negative. So directions, we are choosing like that. And converting units. For now, you don't need, but if mass, unit of mass given in G, then from G to kg, how we are going to convert it? As you know, divide by 1000. So just let's remember these things. And then if unit of velocity given with kilometer per hour, how can we calculate to meter per second? How can we convert to meter per second? Now divide by 3.6. Divide by 3.6, coming from where? Let's explain that now. Kilometer to meter, 1000, right? Times by 1000. And hour to second, 3600. 60 times 60. And when you simplify this, you are getting 1 over 3.6. Because of that, just say from kilometer per hour to meter per second, divide by 3.6. I hope everything is fine. We should just remember directions. And then we should remember, if you need to convert, we must just divide by 1000 and divide by 3.6. This is our, what we have to know before answering these questions. So, question 1. All right, mass 1000 kg, velocity is 8 meters per second east. All right, so for this kind of questions, please write all givens first. All right, what we know, let's write mass equals 1000 kg. So we don't need to convert it because already in kg we can just use it. And our velocity is equal to 8 meters per second. All right, so we don't need to convert this one also. We are looking for momentum. Momentum equals what we know, m times v. M is 1000 times 8. You are getting 8000. As you see, your answer is positive. If you have positive, you can say direction east. Just let's write east for direction, or to the right you can say. And unit of momentum, you remember, unit of mass kg times unit of velocity meter per second. So we have done question 1, but we just add unit and direction for this question. I hope everything is fine. Let's continue with question 2. To the easy questions, let's finish with question 1. Answer is here. All right. So question 2. Calculate the momentum of a boy of 55 kg. running at 12 kilometers per hour. All right. So as you see, unit is different. You must just convert to meter per second. Let's write what we know. We know mass of object, mass is mass of the boy, mass of boy. So boy has 55 kg. Okay. He has 55 kg. We don't need to convert it. And then velocity equals 12 kilometer per hour. 12 kilometer per hour. Okay, let's say. And then we must convert it. Do you remember what we said? If you want to convert to meter per second, divide by 3.6. 12 over 3.6 meter per second. But from now, don't touch it. All right, just use like this. Because if you just calculate it, what you're going to get, if you calculate it, you are going to get less 1. You are going to get, so if you calculate like that, you are going to get decimals. Just leave it like this. Don't touch it. 12 over 3.6. So from now, what are we going to do? Calculating momentum. P is equal to M times V. M is 55 kg. We are using 55 times 12 over 3.6. And you can get your answer, momentum, when you calculate 55 times, and then you are getting 183.333. Just carry on, but we can round it off till 3 digits. Unit kg times meter per second. Kg times meter per second. Okay, let's write kg times meter per second. This is our answer for question 2. All right, let's continue with next question. What are we going to do now? First of all, let's clear all. And then let's go to next question. Let's see what they're asking. Mass is 55 G. Yes, we should convert it. And then going to the wall, a ball just going to the wall and with 10 meters per second. And coming back, rebounds, okay, coming with 8 meters per second. Calculate the change in momentum. So we are looking for just calculating in change in momentum. It means impulse. We are looking for impulse. All right, let's calculate. So let's write all givens first. M equals 55. M equals 55G. 55G. So we must convert 58, sorry, 58G, we must convert to kg. 58 divided by 1000, you are gonna get 0.058 kg. This is our mass. And then what's going on now? They said you have a ball is going to the wall just like this. Let's draw. After that, just coming back after collision, it's coming back. What we have, V initial is equal to 10 meters per second, meter per second. V initial equals 10 meters per second. Okay, sorry about that. Just our writing pad is not helping today. So V initial equals 10 meters per second. It is positive. And then V final is equal to negative 8 meters per second. Now we have all givens. So meter per second, we don't need to convert it. All right, so we can just show solution. Now, let's see. Delta P is equal to P final minus P initial. And delta P is equal to M times V final minus M times V initial. As you see, V final is equal to negative. Your final answer is negative. Because of that, you say your delta P impulse to the left. That's it. So this is our question 3. Done. Let's continue with next question. Question 4. A car with 1,200 kg accelerates from 60 km per hour to 120 km per hour. So V initial is equal to 60 km per hour. V final is equal to 120 km per hour. Let's see what they ask. Calculate the change in momentum. All right. So let's write mass equals 1,200 kg and V initial is equal to 60 kilometer per hour, but we must convert it, of course. 60 kilometer per hour from kilometer per hour to meter per second, you know, divide by 3.6. 60 over 3.6. What we said, just leave it like that. Don't touch it. Because if you just calculate, you're going to get with long decimal. We don't need that. So V initial, we have done. V final is coming now. 120 kilometer per hour. 120 kilometer per hour. And you can write 120 over 3.6 meter per second. All right. So this is our final velocity. We are looking for change in momentum. It means other name is what? As you know, impulse. We are looking for impulse. So let's calculate impulse now. Delta P equals m times delta V. And then what we know, m times V final minus V initial. So m is 1,200 times V final is equal to 120 over 3.6 minus 60 over 3.6, and 1,200 times 120 minus 60 is equal to 60. 60 over 3.6, and you are getting 20,000 units, you know, kg times meter per second. So this is our change in momentum. If they are asking about direction, same direction of motion, because they didn't tell us which direction, just say same direction of motion. We have done last question for today. Another easy question, but now up and down. So 2 kg ball hits the ground at 6 meters per second. It's going down with 6 meters per second and then bounce back with 4 meters per second. All right, let's draw and let's show. First of all, let's just use, you have a ball, it is going down with mass, and then what we have, it's just going up with, this is our V initial. What's our V initial? -6 meters per second. And then V final is equal to positive. What we said, when it's going up, we are going to use positive, right? 4 meters per second. Now we can calculate our change in momentum. Other name is what? Impulse. We can calculate impulse. Let's say impulse equals delta P equals m times delta V. And we just carry on, m times V final minus V initial. V final minus V initial, m is equal to 1,000, oh sorry, just 2. 2 times V final is 4 minus 6. So direction is very important. And let's close out the brackets. And finally, you are going to get 20 kg times meter per second. This is our impulse. Other name is change in momentum. We have done question 5. Next lesson, we are going to carry on with you. What we are going to study next lesson, conservation of momentum, graph, and types of collision, elastic and inelastic collision, we are going to study with you. Thank you very much. See you next lesson.